All right, for this example, we're asked to find the volume of a region D cut from a solid sphere, rho less than or equal to 1, by the cone phi equals pi over 3. So the formula for finding volume is the triple integral over the region D dv. And now in spherical coordinates, we're going to replace that dv with rho squared sine of phi d rho d phi d theta. So that's going to be our equation for finding volume. And now the next thing to do is then to find the limits of integration over that region D. So the first thing to do when finding limits of integration is to sketch a graph. Here I've sketched a graph of what this is going to look like. We've got a solid ball, and then that's being cut by this angle. Phi is equal to pi over 3. So this top surface here is going to be this piece of the sphere, rho is equal to 1. And this cone shape here is going to be phi is equal to pi over 3. So phi, remember, is the angle from the z-axis down to, from the z-axis going downward. So, so an angle of pi over 3 would start at the z-axis, go down pi over 3 radians, and then everything that is that angle from the z-axis is going to be in this function. So that's what gives us that cone there. All right, so to find after we've sketched the graph, the next thing we're going to do is we're going to start at the origin and draw a ray coming out this way. And so at some point it's going to cross out of that sphere there. And we're also going to draw the projection of that ray that we drew down here on the XY plane. We'll call this ray M. We're going to call this projection L. And this angle here is going to be phi, and this angle here from the x-axis over to our projection L is going to be theta. All right, so now the rho limits, let's do the rho limits first. So as you go out on this ray here, we want to know when are we entering D, the region D, and when are we exiting D. And so we're going to enter right at the start, right at 0, at rho equals 0. And then we're going to exit up here when we cross through this sphere, which is going to be rho equals 1. So for our limits of integration for rho, so let's, we've got rho squared sine of phi d rho. Our limits for rho are going to be from 0 to 1. Now let's do d phi. So our limits for phi, we want to know for this ray here, what's the minimum angle that we could have for phi that would still have us going through our region D. And the minimum angle is going to be 0. That would be straight up the z-axis. And the maximum is going to be phi equals pi over 3. That would be at the very edge of this cone. So our limits of integration for phi are going to be from 0 to pi over 3. And finally, our limits of integration for theta. Theta is this angle here, and we can see we want theta to go all the way. We can draw this angle at any point. We could have, any ray that we would have drawn up here, M, would have given us a projection on L that would have been anywhere around this circle. So we're going from 0 all the way around to 2 pi. So our limits of integration for theta are 0 to 2 pi. All right, now we've got the problem set up. Now we just need to evaluate this integral. So first let's integrate this with respect to rho. So we're going to keep sine of phi constant, the integral of rho squared. So let's set this up. This is 0 to 2 pi, 0 to pi over 3. And then this is going to be rho cubed over 3, evaluated from 0 to 1, sine of phi d phi d theta. And if we plug in 1 for rho, we're going to get 1/3. Plug in 0, we get 0. So this is just going to be 1/3. All right, so now to integrate this with respect to phi, this is going to be the integral from 0 to 2 pi of negative 1/3 cosine of phi, evaluated from 0 to pi over 3 d theta. So cosine of pi over 3 is 1/2. So this is going to be negative 1/6, 1/2 times negative 1/3. And then 0, cosine of 0 is 1, so this is going to be minus negative 1/3, so plus 1/3. And so, of course, 1/6, negative 1/6 plus 1/3 is going to be 1/6. All right, so the integral of that then is going to be 1/6 theta, and we're going to evaluate that from 0 to 2 pi. So that's going to be pi over 3 minus 0. So our volume is going to be pi over 3.